Hello. So today we are continuing on exercisms problems. The next problem that we need to solve is this one after the matrix one, which is saddle points. So what this problem asks us to do basically is we get a matrix like this one, and what we want to do is get all the saddle points and return their coordinates. Now, what's a saddle point? It's basically a value where that value is the max in the column. So it's greater than every other. It's the max in the row and the min in the column. So basically, it's a point where it's greater than or equal to every element in the row it's in, and it's less than or equal to every element in the column. So it's basically the max of its row and the min of its column. And it may have no saddle points. For example, if there is no specific value that both it's the min and the max, or it may have multiple, right? And so the problem asks us to return the list of all of these saddle points in the matrix. And so, for example, here the saddle point is this 5 because 5 is the max of this row, right? And it's the min of this column. Okay, so that's what we are asked to do. Now, how do we implement it? So we get the matrix, right? And we have a matrix coordinates that just has the row index and the column index. So what we can do, we want to return a set of these. So that's what we are asked to do. And so we initialize a set. This is just the number of rows and the number of columns. And so we go for every row index, for every column index, we get the value at that specific position, RC. And then we check, is that value both the max of the row and the min of the column? If it is, we add it. Now, checking the max of the row is easy. We just get the index in the matrix of the row, and this gives us the row, so we can just check the max. This is max past the collection, which should work fine. Now, for the min, it's a little bit tricky because we want to pass the column and we want to get the max of that column. And so what we can do instead, this column function is just for each row, get the value in that position. So this would be, let's say, column. Actually, let's name this column. And this would be row. Okay, so what we will do is basically we map through the matrix. So for every row we get just the value in that specific column index, and so that gives us the column, and that's how we do it here. Okay, and then once we have all these points added to the set so that they can be unique, we just return them. We convert them here just to a mutable set because initially it's here to a non-mutable set because initially it's mutable. Okay, so that's a good solution. However, these indices and this add here makes it not idiomatic and less functional than we can make it. So let's just look at another variant here. So let's compare. So we still have the same way we are getting the column. However, you can see it's a lot shorter, and instead of doing this indices here, we can just map through the matrix, right? So we can just map and use. For our mapping, we can just get the index of the row in the row itself. And then once we get the row, we can map through the row to get the value and to get the column index. And then to do this check here that we are doing here for the max and the min, max of the row and the min of the column. Max of the row is easy. Min of the column, we do the same thing we did here, right? We just get the column and we get the min. And then we, now one thing I didn't clarify previously, we are doing R+1, C+1 because in the problem here, this 5 here is counted as column 1, row 2, right? So column 1, row 2. So this is row 2 for this problem, which means we started indexing from 1. You can see it here, we start indexing from 1. And so +1 here for the row and column is just to, because because the normal indexing is starts from 0, and so here since it starts from 1, we just need to add 1 to accommodate that, right? Okay, so now that we do this map index, if it's a saddle, which is what this check does, we return it. If not, we return nil. And because we are doing map indexed not nil, those nil values will be filtered out, and so we'll only get these coordinates that are really a saddle. However, because we have this inner map, so this will return a list of matrix coordinates. So we'll get a list of lists, right? So you can see here, if I do it like this, you can see we get a list of max coordinates here, right? And so we want to flatten it so that we can get first a list. So now you can see if we do that, we'll get a list of matrix coordinates, and since we want them unique, we want to convert to a set. So yeah, this is a lot more functional and a lot more idiomatic, I think, Kotlin. Okay, so once we do that, yeah, this solution should work fine. Another additional improvements we can make is, you can see here what we are doing is for each value, we are computing the max from scratch, the max of the row and the min of the column. We are doing it for each value, and then we are doing it, yeah, so we go for each row, we go for each value, and we calculate the max each time. So can we do better than that? And that's what this solution does. So what we do instead is we pre-compute the max of each row and the min of each column. We use lazy here so that we don't calculate until we need it. Not necessary, but just if you had the max function called multiple times on the matrix, if you needed to call it multiple times, then this would be it would be called only when it's needed. So basically you could do this. This should work fine. Like this should work fine. But I just prefer to do it lazy here. But that's not the interesting part. The interesting part is we take the max values. We take the max of each row. So we have in this here, we can just do row max.r to get the max of a specific row. And we do a similar thing for column min. So we just take the columns, we map, and we get them in. However, how do we get the columns, right? We'll take a look at that. But the point is that here in this check, instead of recalculating it, we can just check is this value equal to the row max at this R position? We are not calculating, we are just accessing what was calculated here. And we are doing a similar thing here for column min, so it's calculated just once. Now the only remaining part is how do we calculate this column, right? So in the same way that we just go through each row and we get the column index, here we want all the columns. So first we go through all the possible column indices, and that's just from 0 to the size of the first row, right? That's the number of columns. And from there we get so these are the indices of the columns. So we map through them, and for each row we get the value at that column. And so that will give us a list. This here will give us a list of columns. And that's what we can do here so that we can map it and just get the minimum. And the rest here can stay the same. Yeah, so this would be more efficient. And yeah, that's pretty much it. The variations that I wanted to cover for this problem. Please like and subscribe, and see you on the next one. Bye.